Hello dear students. In sulfur system last class we studied significance of curves. Today we are going to study significance of areas. So in that first one is the area sulfur rhombic. So curve AO, OC and CD. So here in these three curves the common phase is sulfur rhombic. How? Here in AO curve it indicates equilibrium between sulfur rhombic and sulfur vapor, and in OC curve indicates equilibrium between sulfur rhombic and sulfur monoclinic, and here it indicates equilibrium between sulfur rhombic and sulfur liquid. The common phase is sulfur rhombic, so it will occupy the area between AO, OC and CD. Here the sulfur rhombic is more stable. So when we apply the phase rule, degree of freedom F is equal to C minus P plus 2. Composition is same sulfur, and here phase is also same 1 sulfur rhombic. So degree of freedom is 2. 2 means there is only two variables, temperature and pressure. When you are studying curve AO, here the degree of freedom is 1, means there is only one variable, either temperature or pressure. But here in significance of areas, what happened? The degree of freedom is 2. It means the two variables, temperature and pressure. And next one is the area sulfur monoclinic, the curve OB, BC and CO. Here OB curve shows equilibrium between sulfur monoclinic and sulfur vapor, and BC curve shows equilibrium between sulfur monoclinic and sulfur liquid, and here the curve OC shows the equilibrium between sulfur monoclinic and sulfur rhombic. The common phase is sulfur monoclinic, so it is more stable and it occupies the area between this triangle. Degree of freedom is 2. This is also bivariant, two variables, temperature and pressure. And next one more area is sulfur liquid, the curve BE, BC, CD. So here the common phase is sulfur liquid. This is more stable here and it occupies the area between BE, BC and CD. Degree of freedom is 2. So this is also bivariant. And last area here sulfur vapor, this area. So here the curve AO, OB and BE. So here common phase is sulfur vapor and occupy the area below these three curves. Understood? So degree of freedom is 2. This is also bivariant, two variables, temperature and pressure. So this is about significance of areas. And next one is triple point. First triple point is here, this point O. Here at this point the curve AO, OB and OC, these three curves will meet here. So here in this point sulfur rhombic is equilibrium with sulfur monoclinic and this one is equilibrium with sulfur vapor. So when we apply the phase rule, F is equal to C minus P plus 2. Composition is 1, same sulfur. Phases are 3. One is sulfur rhombic, another one is sulfur monoclinic and third one is sulfur vapor. So degree of freedom is 0. 0 means this is invariant. Invariant means the variables such as temperature, pressure and composition remains constant at this point. Correct? Next point is this one, B point. Here three curves BE, BC and BO. These three curves meet here. So at this point sulfur monoclinic, sulfur liquid and sulfur vapor are equilibrium with each other. Degree of freedom again same 0. This is also invariant. And next one is triple point C. Here again three curve will meet each other here. One is BC, another one is OC, and this one is CD. So here sulfur rhombic, sulfur liquid, and sulfur monoclinic. At this point these three phases are equilibrium with each other. Degree of freedom is 0. This is also invariant. And the last triple point is A dash. So three curves will meet here. One is BA dash, OA dash, and CA dash. Here when you studying this triple point, we should neglect these three curves. So it means at this point sulfur rhombic, sulfur liquid, and sulfur vapor are equilibrium with each other. This system is also invariant. Degree of freedom is 0. And the last part of this sulfur system is metastable equilibrium. Here along with AO curve, the slow increase in temperature then at 95.6 degrees Celsius sulfur rhombic is converted as sulfur monoclinic. This is natural slow process. So if you increase the temperature rapidly or if you increase the temperature suddenly, what happens? The sulfur rhombic is not converted to sulfur monoclinic. So this is metastable equilibrium between sulfur rhombic and sulfur vapor. Correct? This metastable equilibrium is represented by dotted curve OA dash. Similarly, along the curve EB, sulfur liquid here equilibrium with sulfur vapor. If slowly temperature is decreases at 120 degrees Celsius, sulfur monoclinic is not separated out. This metastable equilibrium will exist between sulfur liquid and sulfur vapor. So this is shown by graph. Then A dash C represent metastable equilibrium between sulfur rhombic and sulfur liquid. This metastable equilibrium is only imaginary, it does not exist.